Okay, so my name is Thomas.
Hi, Thomas.
I'm here to talk about improving your Flask APIs using a library called Flask RESTful, and a little bit later on in the talk, flask-restful-swagger, which is a way of documenting your APIs. So a little bit about me. My name is Thomas. I'm an engineer at Thinkful, which is a company that teaches people how to program through mentorship. I've been writing Python for 2 years, and I'm on Twitter and GitHub. Okay, so I want to start by introducing APIs a little bit. So when I say API, there are lots of different kinds, but I'm specifically talking about a web service. That is, there's a server somewhere that has routes, and you're requesting a resource from that server. And specifically, a RESTful API. RESTful stands for representational state transfer, which means that there's a resource, like an object, that you're representing, and you're passing it between the server and the client. You're passing it state. And there are 4 constraints of a RESTful system. One is that there is a client and there is a server. That it's stateless, which means that the server doesn't have to know that the same client is making requests across multiple requests. So one request to the server doesn't have to have any, or contains all the information for the response. The third is that it's cacheable, which means that a client can cache the response from the server. And the fourth is that it's layered, which means that the client doesn't have to know which computer it's connected to, which server it's connected to. In sort of a CRUD system, you have these 4 operations: create, read, update, and delete, which are operations that you're performing on the resource. Now those map really nicely to HTTP methods: post for create, get for read, put and patch for updating a resource, and delete maps to delete, surprisingly. Okay, so if you're sort of new to Flask, you might want to make an API by creating view functions and then tying them to routes like you would just normally. And here we have an API blueprint, which is something I'm not covering, but it's a sort of way of namespacing your routes. And I have a projects. I don't know if, can everybody see these? Okay. So we have projects and projects with a project ID. It has some get operation, and then there's a separate post projects view function that is on the same route, but with a different method. The default method is get, so it's not specified here. So this is fine, and this works, but we have these 2 route decorators. We're calling JSONify here, which is a way of turning your response into a JSON response. It's just convenience. We're calling toDict to get the representation of the resource, which is assumedly a function on the instance project. And we're actually explicitly putting the envelope, which is, it's like a wrapper around the resource representation. Here, it's projects is the envelope, and the resource is this collection of projects. So there's a better way to do this in Flask, using Flask pluggable views. And it's this way of sort of generalizing your views into classes so that they're reusable. And specifically, I want to touch on one version of that called method view, which uses a thing called method-based dispatching. Now you can name your functions in that class whatever you want, but in method-based dispatching, the name of your function in your class definition maps to the method, the HTTP method, that function is run on when a client hits the route associated with the route that's registered with the class. So this is a lot better, but it's a little bit more resource-like. You have these like get method, post method, but it's still a little bit messy. You can see getting this set up is a little bit messy. It looks kind of messy. So we have a better way to do this. And that better way is a library called Flask RESTful. Now, Flask RESTful is actually built on top of MethodView. So it has that same structure where you have a get and a post method that's defined on your class, and that maps to HTTP requests coming in to the route that your resource is registered on. The main thing here is that we have, or that Flask RESTful is resource-centric. So you create classes that represent a resource, and then you expose that resource via a route that you register on your API, which is in turn an extension on your application. Okay, so I have an example here. I have a little example app. I just called a project tracker. And let's see, this is a little bit squished, but here it is. Oh, well, let's take a look at the code first. So here are my resource models, and I have these are using SQL Alchemy, if you're familiar. It's an ORM, and it's defining, it's mapping to a table in this case, SQLite. But I have my columns, and this will sort of represent our resource object in the Python code. And then over here, I have my resource definitions, and you can see that this is a class that is subclassing resource, which is from Flask RESTful, and it has this post method, it has this get method, and all this get method is really doing is returning the list of all available projects. So this is a project list resource. It's just going to return all the projects. And here I have a single project resource, which also has a get that takes a project ID, and it does a filter based on that ID, trying to get a specific project, and it's returning that project object. Now, this is actually returning the Python object. This is not returning a representation of the Python object, and we'll get into why that is in a minute. Okay. Similarly, I have a progress resource over here, which is represents some progress on a project, and I'm going to show you the application that these are used in right now. So this is the front end to this API, and you've got a project that you're creating, and then when you create a project, you can see that over here we've got a 201 for that project being created, and this project has a goal, and then if we add time, we're adding sort of progress to that goal. And what is happening here is that we have a direct mapping for objects over here, the way that we're representing it on the client, into a resource on our server. And we're doing that through the representation in Flask RESTful of the resource as a class. Okay, so now I want to go a little bit through some features of Flask RESTful and how they might be used. So one of the really interesting things is how you would use decorators. And pluggable views exposes this attribute called decorators, which you can pass a list of decorators that will run before any of the functions on that class. But Flask RESTful takes it a step further. It gives you an attribute called method decorators, which will run on any subclasses of that. And if you have a pluggable view that defines decorators, it won't override method decorators on the superclass. So there are lots of different things that you can use decorators for. Authentication, for example, if you want to log requests or do some simple rate limiting in Redis. You can, for example, have different rates for different resources by defining different decorator lists that maybe takes in the same decorator but with different attributes, that limits differently based on the resource. And I have an example of it in the code here. In my project progress, I have these two decorators. One is, well, I have three decorators. One is just logging, and then one is logging based on whether it's a post or a delete. You'll see in the application, when I post here, you get the first decorator that's saying, here comes the progress post request for project 1, and it's got the payload, and then the second decorator, which is just giving the request an ID, and then setting it on the Flask global object here. And then the view function runs, and then you have a second log that's saying, this request is finished. And then when you delete, same thing, but the delete decorator is running. Okay. Next we have error handling, and Flask RESTful sort of provides you with this this framework for catching errors and returning the response that you want to return, as opposed to just throwing a 500. And it's done like this. You have this dictionary of errors with a status and an optional message, and then you register it when you register the app or register the API on the app. And you can take a look at an example of that here. So it's a bit contrived, but I have on my project progress resource, it allows for negative values to be put in, and obviously that's no good. And when we're writing the API, we don't want to sort of assume that the client is going to catch all of those errors. We want to handle that on the back end as well. So in my project progress resource, I'm going to go ahead and on the post, if the value that's passed is less than 0, I'm going to raise this negative progress error, which I've defined here. But whoop, did I restart? What's happening there? Oh, I didn't save it. Okay, there we go. So we have a 500 now, which is not what we want. Our application is throwing this error, it's not being handled, and it's resulting in a 500. So what we can do is go into where our API is registered here and catch that negative progress error, and then send back a 400 saying, this is a bad request. Progress can only be positive. So when we do that, we see we have a 400 over here. If you looked in the inspector, it would say the message. Okay, so that's error handling. Oh, also, Flask RESTful provides you with this, this other method called abort, which is somewhat like Flask's abort, which sort of hijacks the request and sends back an error response, usually. But it's a little bit different in that abort for normal Flask takes 2 arguments, the response status code and a message. And in fact, if you try to just replace it with the Flask RESTful one, it breaks because the Flask RESTful one only takes 1 argument, and you have to specify that the message is the error message using the error keyword argument. Okay, so this is sort of the most interesting part. It's about how you're mapping an object into a representation that you can then send back. And this is, you remember when I said we were returning a Python object from the method on the project resource? This is what turns that Python object into a representation that can be then sent back to our client. It's called Marshall, and there's a convenience decorator called Marshall with, and it takes an object and it takes some defined representation of that object. In my example, I've defined them on the classes. And it takes an optional envelope, which, if you remember from earlier, wraps this representation in this object, which is the envelope project here. And you can take a look at what that looks like on the model. Flask RESTful provides you with these things called fields, this module called fields, where you can define an API representation for a resource. And here's the API representation of project progress with the fields all defined. And then here's the representation for project. And you can notice that, that we have this nested field, which is the progress for a project. And you can pass it in another representation. And Flask RESTful will just take that and sort of coerce your object into this, this representation that then you can send back to the client. It's really nice. Okay. So lastly, I want to get into Flask RESTful-swagger a little bit. It sits on top, it's a library that sits on top of Flask RESTful, and it lets you document your APIs a little bit. Swagger is a framework for API documentation, and this is just a library that's written to that framework to help document your APIs. And the way it works is via a decorator on your view functions. So this sits above the method defined on the resource class, and it takes in a bunch of information, and then when you want the specification for your API, it just spits out a bunch of JSON that represents that specification. So here I have, in the code, we can see these Swagger operation things above the methods, and they have parameters, they have messages that are that you're gonna get back from the resource, or from the method, and that's fine. And then if you go to /API/spec, by default, you get this representation of your specification, which is nice, but it's a little bit unreadable. Like, I'm not going to look through this for any details. So if you just add HTML to the end of it, you get this, which is a really nice client for dealing with your documentation. So if I click list operations here, you can see these are my resources with their routes and the methods that are available on them. So here's my list resources with get and post, my list projects, my individual projects, listing the progress and individual progress. And what's really cool about these is that you can actually click in here and click try it out. It'll just make a request and show you the response. So here I have the response from my API. It's the list of projects that I have. And I can even go down here to post. And I have something to throw in here. So this is something that should cause a 400 for my project when I'm trying to post and create a new project. And post that, and I get this 400 with the error, I'm missing this field, this particular field. So if I go ahead and add that field, I get a success, a 200 or a 201, which is created, and that representation of my resource. And if I go back here, refresh this, it shows up right there. Same deal with creating progress. And go down here to where I'm posting new progress. Put that in here. Let's put it on project 2. Click that. Get a response back and refresh. There's my progress right there. So you can see that this is a great tool for debugging and checking your APIs as well as documenting. It's really easy to set up, and it just makes the whole process a lot less painful. There are a couple of other things. I didn't touch on taking a representation and deserializing it. There's part of Flask RESTful that's for this called recparse, but it's being deprecated. And there are alternatives like Marshmallow. There are also class decorators for Flask RESTful-swagger, which sort of inspect your resources and try to automatically create the documentation. Finally, all this code for my example application is on GitHub, and there are the links to the libraries here. This slide deck is available on slides.com/Thomas Peterson. And that's all. Any questions?